So this deck was 90% produced by an AI agent, and it was written on Spring and Kotlin. So it's written on the open source agentic system on Spring and Kotlin that I'm going to talk about. I've spent the last 10 to 15 years experiencing different languages because the JVM is not the answer for every problem in software. There were things that I was doing that either required experimentation with different JVM languages or were completely different platforms. And I'm actually really glad that I did this because, looking back on my career until, say, 2010, I had worked exclusively in C family languages. C, C++, Java. So since then, gone a little bit broader. And my first major language fling was with Scala. That was probably about 13 years ago. I was really into Scala. It is quite beautiful. Unfortunately, humans are not worthy of Scala. And they're certainly not worthy of the Scala community. Basically, the Scala community does have really a pretty big thing about making people feel bad if they're not sufficiently monadic. So Scala introduced some lovely ideas, and for example, the fact that any compound statement can return a value. I've been programming in C family languages for 20 years, and it had never crossed my mind. C had been around for 40 years, and it had apparently never crossed people's mind. And Scala, Martin came up with that, and it was just beautiful. Secondly, I did something quite different. I did a project that involved a lot of Node, and I did TypeScript. I really like TypeScript. I think they've done an amazing job of retrofitting a really rather nice, strongly typed language onto the underlying chaos that is JavaScript. There are still things that I miss about TypeScript. So I really miss union types. Side rent, sealed hierarchies are absolutely not as good as union types, but anyway, that's getting a little political. I love the language, but I don't love Node. I don't hate Node. Node's a really good tool, but it really is not the JVM with Spring. Things, with Spring, typically you have one way of doing something, and it works. With Node, you have 50 ways of doing it, because there are 50 different libraries. Maybe 2 or 3 of them work. But, it is a very messy ecosystem. And it's surprisingly effective, but when you start digging, you quickly get into painful areas. Like the language, though. Then I started getting really interested in various flavors of AI. So naturally, as you think you need to, I turned to Python. And I'm kind of glad that I did, because by the time I came back to the JVM, I was completely fluent in Python. And Python, 3.10 and above, is so much better than even early Python 3. I mean, it's actually getting pretty good with type hints, but nevertheless, it doesn't feel right to me for a language to build complex applications. So when I was starting to build something that was obviously going to be a fairly complex application, I turned back to Java. And I thought, I haven't written Java for over 10 years. I need to be familiar with modern Java, with records, var, all the things that have come in, the enhanced switch statement. And I discovered that actually switching from Python back to Java and Spring, despite the fact that at that point I was highly fluent in Python and I was, believe it or not, quite rusty in Java, I was instantly more productive. And the major reason for that was Spring. I kept running into these things in Python where I was thinking, you cannot be serious. We solved this problem in Spring with Spring in 2003, and you're still doing it from first principles. Then I got rather frustrated with Java collections, which are still bad. And I also got very, very frustrated when they pulled the string template, string interpolation, out of the JVM preview. I guess I'd been living on the edge. I had embraced this feature they did warn me it was experimental. And when they pulled it out, I was having to change, I think, 300 places in my code. So at that point, I thought, okay, I'm going to try Kotlin. And I have not looked back. I will certainly not ever be one of these people who hates Java. I think Java is a pretty good language. I think they're doing a surprisingly good job of evolving it within Oracle. But honestly, for the things that I do, Kotlin is simply better. The code is more readable, it's more pleasant to write, it's just better. And guess what? For people who are going to use my library, I hope also from Java, they don't need to care that it's written in Kotlin. From Java, it is completely idiomatic. There is no interop tax. So Kotlin really gives you the maturity of the JVM for server-side things, complete interop with fantastic Java libraries and frameworks, and a truly modern language. The JVM, by the way, as I said, these slides are 90% generated by my agent. So I may not have phrased it quite like this, but it's not bad. The JVM has a lot of good things about it, which we can take for granted sometimes. But it is an incredible piece of software that truly does get better and better. Spring, obviously, is everywhere, and there are very good reasons that it's everywhere. It is extremely consistent in its approach. If you know how to do one thing with Spring, you know how to do another thing with Spring. One reason for that, of course, is Spring's insistence on consistent naming and patterns. We have, of course, had a lot of people make fun of them, but you know what? They work. And when you ask an LLM questions about Spring, you get an even extra unexpected benefit about the complete consistency of Spring naming and patterns. So it's one-stop shop. You've got Spring Boot for rapidly creating apps, Spring Security, Spring Cloud, and it really works now for any scale of application. But also, Spring now provides the structure, the backbone, if you like, for much of the world's most valuable code. Kotlin, I see as a very pragmatic modern language. Why is it good? Well, I probably don't need to spend too much time on that to this audience. It's quite concise, it's expressive, null safety is a very good thing. Extension functions, I started off a little skeptical about, but I've now got extension function religion. I can see how they can be used quite safely. Kotlin obviously has a really nice way of creating DSLs, but some of the things that most appeal to me is that it's highly readable. We spend much more of our time having to read code than we do writing it. And I love the fact that Kotlin code I find extremely readable. It's funny, when I switched to Kotlin, I actually discovered, somewhat to my surprise, that there was something that I actually had liked about Python. And that was the Python formatting conventions and obviously having named arguments. And it's strange that visually, if you don't know how it works, Kotlin actually looks more like modern Python than it looks like Java. And I actually discovered, to my complete surprise, that I like that. But of course, Kotlin gives you a lot of things that you don't get in Python, like a good type system, better tooling, etc. The interop with Java is great. I honestly don't know how they've done it, but it's extremely impressive. I remember the days of working with Scala and all the hoops we had to jump through to marshal collections to and from. It's just painless. I find that in dealing with collections between languages, occasionally I get a minor annoyance in Kotlin where I need to use a mutable list or something like that, but it's exceptionally minor. It is absolutely nothing like the pain with Scala. But also, I think Kotlin, as I said, very pragmatic language. It is chosen, and the community have chosen to play nice with the Java ecosystem. So in Scala, there was obviously a lot of functional zealotry, but there was also the desire to reinvent every wheel in sight. So, Scala people were far too good to consider using a Java library for anything. The problem was they were starting from first principles with maybe 1% of the number of people who were using the Java libraries, which meant that it would have taken them longer than the lifetime of Scala to actually get to something that was as reliable and mature as the Java stuff. In the Kotlin world, things are not like that. In the Kotlin world, there seems to be a pragmatic willingness to build some things in Kotlin where it makes sense, but also to fully embrace Java things. And of course, that has been repaid by Java projects, most notably Spring, putting in the extra work to put in non-null annotations, Kotlin extension functions. So I find that quite beautiful, that it plays nice with the Java ecosystem. I can't really find words for this, but as I was saying to Sebastian at the speakers' dinner last night, I find Kotlin just feels comfortable. I just feel really at home, and it's partly because, although obviously it benefited much from the learnings from Scala and other more academic languages, it feels like it was created by practitioners. Like very often I find something in Kotlin, and it's as though somebody on the language team or the core API team had encountered this problem that I'm just encountering, and they'd thought of it, and they've put this nice little method in that does exactly what I want. So yeah, I just find that very, very comfortable. Kotlin and Spring work really well together. So Spring annotations work great in Kotlin, obviously. Annotations in Kotlin are very compatible with Java annotations. One particularly nice example of this is Kotlin data classes and Spring configuration properties. Works beautifully, and you get the Kotlin defaults that you don't get in Java. Null safety obviously integrates very well with Spring because the core of Spring has non-null annotations. And there is close, and obviously as we heard this morning, closer and closer cooperation between the teams. So there's the Kotlin compiler plugin for Spring, there's Spring extension functions, non-null, and more is coming. So when we look at something like using @service in Kotlin, it's pretty much like Java, except it's a little bit nicer because you have the more concise syntax in Kotlin. Of course, you don't need to use the open keyword there, and I'll get to that in a moment. But it's clean, idiomatic Kotlin. Again, as I said, this deck was auto-generated. In the brief that I gave my agent for creating the deck, I said what I wanted to say, and I said, give an example of a service, show how the open annotation works. So it pulled out this example. So data classes, configuration properties, very, very nice. Exactly the same as it works in Java, except you've got the power of defaults with Kotlin. But totally idiomatic in Spring as well. Some of the fancier stuff in Kotlin, like reification and type-safe generics and extension functions, work really well when you're using Java libraries. And I think that is certainly one of the major arguments for those features. One thing I would say that we should bear in mind if we're writing server-side Kotlin is don't forget about Java. Don't do what the Scala people did. Remember that you might be writing something that if it becomes popular, there's a lot of Java developers in the world, and they might be using it. So for example, if you're writing something open source, reification is wonderful for Kotlin people, but it's not available to Java people. So make sure you have the form of your method that you can call with class O, etc. Java consuming Kotlin, really nice. Most of the time you don't notice it. So I've found in building a framework that is intended for both Java and Kotlin users that I have written probably at this point about 15,000 lines of Kotlin and 300 lines of Java. And it's basically I felt that it was annoying in Java to see any KT imports. And then when I started pulling on that thread, it went a little bit deeper. So I have two pretty trivial classes that just ensure you don't see that and have one aspect of the project be idiomatic in Java. But it's like a very, very small investment, and now from Java, it's completely idiomatic. So I mentioned open. Again, this is an example that my agent pulled and put on a slide for me. I hate creating slides. It is very important to remember that Spring needs to do a lot of things through proxying, and there are very strict limits to what you can do with final classes. And you can silently get errors or get errors that have warnings you perhaps didn't notice, and your app doesn't do what you wanted. So configure, the Kotlin open plugin for Spring. In this case, this is how you do it in Maven. You can do it obviously in Gradle as well. Very important, it will save you a lot of pain and it will keep your Kotlin looking nice. So as I said, this deck was built by an agent. The input was a YAML file describing the narrative that I wanted, and all code examples were taken from the source code by the agent. So, this isn't just a demo, this is real. You can go to the open source page for Embabel. You can actually see the code that created this deck and the other examples and experiment with it. Why do we need agents? Okay, at this point you might be thinking, well, LLMs are getting really, really good. They're really smart. We've got MCP. It's all over. It's all done. Why do we need agents? I, over breakfast, was running through my slides while simultaneously scrolling on my phone because I can't bear doing one thing at once. And I saw this article from The Economist, which basically points out that the promise of AI is awesome, but the reality, particularly in the enterprise, has been quite disappointing. And people are, obviously certain use cases like chat are great, but making it useful in business applications is really hard. And this is why you need orchestration. So I would say these first points on this slide are necessary, but not sufficient. Better models. Better models are great, but they are not sufficient because improvement in the model landscape is probably slowing. And secondly, if we have better and better models, we become really dependent on God models to make decisions for us. And that can be quite unacceptable in many, if not most, business scenarios. Similarly, MCP, Model Context Protocol, very important technology founded by Anthropic, but now, spreading everywhere. MCP is good. I hesitate to say great. It's good. It's very important. It's an essential integration technology, and it's fantastic it exists, but it absolutely doesn't solve problems like discoverability or control flow. Similarly, frameworks in the space of Spring AI or LangChain, it's important, but it's really the underpinning of the next level on which we need to build applications. I see that, for example, as analogous to the servlet API. It's good the servlet API exists, but no one's built a Java app directly using the servlet API for 20 years. So it's the wrong level for sophisticated applications. So you really need powerful approaches to orchestration, and this is what brings us to agents. And it addresses things like predictability, understandability, enhanced safety, and ability to mix models. Because for privacy reasons, for cost reasons, we may want to do certain things with models that run inside our firewall. Those models are not going to be as capable as Claude Sonnet or GPT-4.1, but there are many things that if we factor our applications into agentic flows, there are many things that they can do. So Embabel is the framework that I have actually launched yesterday. It is an agent framework. It's written in Kotlin, built on Spring, and on Spring AI. And it models agent flows in terms of actions, goals, and conditions. And I think one of the things that is novel about it is that it introduces a planning step. Whereas if you look at technologies like, say, LangGraph in the Python world, you're specifying the flow of a state machine. It's the most obvious way to do it, clearly makes a lot of sense to model flows, but it's not very extensible because if you need to add more actions, you've potentially got to rewire your state machine. So you may have to tear up some existing code to add any enhancement. How Embabel works is quite different. So it has the notion of goals and actions. It chooses a goal and it works out how to get to that goal by chaining together actions known to the system. So it uses a non-LLM AI algorithm in order to do the pathfinding, the planning towards the goal. This means, for example, if you add more actions and more goals, your system can become more capable without modifying any existing code. Another thing that is different about it is that it emphasizes a rich domain model. So you're not seeing the kind of heavy emphasis on maps that you see in a lot of the Python stuff. It even goes beyond what we see with pydantic models, which are good for validation, in terms of adding behavior as well to domain objects and even exposing that to the LLM as tools. There are two programming models. One is annotation driven in Spring style. Another is a Kotlin DSL. I think the Kotlin DSL could be improved a lot. So, I welcome all contributions, but, people from the Kotlin community who are awesome with DSLs, I think could really, really improve that part of it and make it extremely compelling. Okay, I talked about the planning idea. So there is a planner, of course, in good Spring fashion. It's pluggable. The planner that is used out of the box by default is the GOAP planner, Goal-Oriented Action Planning. GOAP is an algorithm that is virtually unknown in the enterprise, but I would say any enterprise developer who's ever played a game, which is probably quite a high proportion, has almost certainly been killed by a GOAP AI. GOAP is one of the two predominant technologies in gaming for controlling the behavior of non-player characters. And it is this planning model from a world state. I don't know if you can see this here, but on the left there, we have the present world state. So this character has weapon nearby and is alert. They're not hurt. The enemy, unfortunately, is not dead, but at least it's not near a threat. So from any given world state, you can plan towards a goal. So when I was doing some research about this kind of algorithm, I realized that GOAP is actually very similar to an incredibly old AI algorithm called General Problem Solver, or GPS, that I remember learning about in computer science many years ago. There's only so many ways to express these ideas, but the pathfinding idea is very powerful. When it chooses a path towards a goal, even though it's an AI algorithm doing the pathfinding, it can tell you why it did it, and it's rigorous. It can basically give you a trail of, I chose to go to this goal because I think if I do this, it will meet the preconditions of that, I do that, I do that, I do that, and we get to the goal. After it's executed every action in the chain, it redetermines the world state to see if the expected post-condition of that action had occurred. So this is how it looks in the Java-style annotation model. So here you can see that we've got an @agent. This is the part of the presentation maker agent that actually literally built this slide about itself. And we have action annotations that are rather similar to, say, Spring MVC controller annotations. And essentially, by default, the preconditions and postconditions are computed by looking at the parameters and return types of these methods. So, as I mentioned, the Kotlin conf presentation YAML file is what this presentation was generated from. So let me show you that. So it looks like this. So here, notice that's where that table came from. So it's actually my content, but I said make it a table. Provide all examples from the given code base if possible. I gave it the path on my machine to the source code to use. And also this is using a framework that was actually developed by the Singapore government for kind of shaping LLM responses. So COSTAR, which stands for context, objective, style, tone, and audience. So actually what happened as the presentation was built is there wasn't one LLM call. There were probably about 15. So firstly, it used a good LLM to say, okay, given this presentation brief, what things would you need to research either from the code base or from the internet to back up the statements that the presenter wants to make? Then it went off in parallel, and for, I think, 10 different research topics, it had specific sub-questions, and a cheaper LLM used MCP tools to research each of those topics. Then it used a good LLM, Claude Sonnet, which is probably the best LLM, to generate the content in Markdown. Then it used an action that was purely written in Kotlin code, which called the MARP, M-A-R-P, Markdown to slide generator to produce the HTML deck. It's very important to be able to mix and match LLM and code-based interactions. One of the ways of doing that, obviously, is tool calls, like MCP enables, but that is certainly not the only important way, because potentially that's somewhat risky. So, for example, I experimented with using some GitHub tools, and it was quite good for looking at issues and things like that, but I also discovered that it had raised some issues that I hadn't actually asked it to do. So, if you give MCP tools to your model, you can't always predict what it will do. Whereas if you do a mixture of giving the most relevant MCP tools and doing other things in code, it's much safer. So for example, the things that had side effects on the file system were actually persisting the markdown and writing the markdown to HTML. They were driven purely in code. The MCP tools to pull examples from the deck are given read-only file access. So there's no way that an LLM could erroneously have started to do bad things to my hard drive. So why is Kotlin and Spring good for the agent framework? Well, firstly, I think that the key adjacency here is not to the LLM. The key adjacency is to the code that you already have and the understanding of the domain that you already have. So a lot of people assume that Python is where it's at for building, LLM orchestration systems. I believe that is where it has been at, but I don't think it's where it will be in future. Because the adjacency is not to the LLM. The LLM is an HTTP call away, and it's a ridiculously simple HTTP call. And now we have, for example, with Spring AI and LangChain for J, we're at parity with all the Python stuff for smoothing out all the quirks of different models. That's a solved problem. So really, the adjacency is with the code and the domain understanding you have, and also with the services, the enterprise services like robust messaging, like persistence that you already have, and with the frameworks you already know. So next steps, try Embabel. I will give you a quick demo to end the talk. Experience agentic systems powered by Kotlin and Spring, and help us build the future on Kotlin and Spring. Okay, let's have a look at how this works in practice. So this project is out there at GitHub. So the project is, oops, no, that is the wrong one. Never do a live demo. Embabel agent. So, yes, this is the correct one, and as you would expect, the build is passing. So, on GitHub, ready to go, all open source. So, I am going to start it up in the Spring shell that it bundles with, which is the easiest way of getting going. I mean, obviously, it's not how you'd use it in production. You will notice here that we have logging that is Star Wars centric. There are two reasons for that. One is that it's fun. And the second is I've always wanted to do logging properly. I wanted to retrofit this kind of thing with Spring. There is debug logging in the implementation classes, and all other logging comes from events. And therefore, it's absolutely trivial to swap in Star Wars or any other personas. So all of those log messages contain data that could go over the wire, for example, with WebSockets or go onto a message bus. So what it has done is deployed a number of agents. How did it find the agents? It found the agents through basically Spring Boot class path scanning. So here you can see an agent. At agent is a Spring at component stereotype annotation, so it's automatically picked up. It's automatically injected by Spring. So for example, this particular thing needs a horoscope service. Where does it come from? Well, if you use Spring, you know where it comes from. Exactly the same as any Spring application. Okay, let's ask it what agents it knows about. So the agents it knows about have been found by from the class path. But here, for example, we have the star news finder. What this does is, from user input, finds the name of a person and their star sign. Then it calls a horoscope service. Then it asks an LLM to say, in the light of that horoscope, go and do research for current news that might be relevant to this person. Then it brings the news back and it says to another LLM, okay, you've got this person's horoscope and their name and the relevant news, write up something that will be kind of funny. So you can see that it has a goal and it has a number of actions. And these actions have pre and post conditions. So what we're going to do is firstly run it. So we're going to say, Linda is a Scorpio, find news for her. So the first thing it's going to do, based on this input, is choose an agent to run. So use an LLM to work out which agent is appropriate to run. If you said, for example, get me a new car for free, it will say, I'm sorry, I don't know how to do that. So it will choose an agent. Then it will create a plan, and we can go over these log messages when it has finished. It's now calling MCP tools. So this is the LLM is calling tools to search the web. It is now ready to do the final write-up, and it has finished. So let's see. Streamline your mental shelves. So you can see it's used a number of LLMs. It tracks all the LLMs it uses in any agent flow. And it also tracks the cost of all the calls. So that cost, obviously it needs to use a database of LLMs, and the costs do keep changing. So you have to be aware of that. But it's very powerful in the ability to work out what your usage is. Also, as far as I know, it's unique among agent systems in that it has the ability to expose the cost to agents. So it can put the cost in an out-of-band response to an intercepted MCP tool call. So for example, it can say, you're using too many tokens, slow down. Or alternatively, it can modify the prompt for a particular interaction to say, slow down, you're already getting close to your budget. It also gives you the ability to specify budgets and hard cutoffs. So, for example, there are two ultimate cutoffs in case your agents go a little haywire. One is absolute max number of actions, and another is budget, like where it will just hard shut it down. So you can't. You do, particularly if you're using agent systems on any technology, do be careful to set budgets because they can actually use quite a lot of cost. Obviously, this didn't because it used GPT-4.1 Mini and GPT-4.1 Nano that are pretty cheap, so it cost 1/10 of a cent, so not too bad. Okay, let's see how it actually did the planning. So, first thing it did was chosen agent. Chosen agent I have with confidence, 0.95. Seems pretty conservative confidence for that input. Then it created an instance of the agent. The reason it creates a distinct instance is the agent might have actions that are not relevant to the present world state. So you create the most focused, streamlined version of that agent. So next, it looks at the current world state. So the current world state includes values for everything that it knows that it might have to compute in the execution of this flow. And notice the only thing that is true currently is that user input exists. So then it creates a plan. And it has created a plan that says, okay, from here, I think I can extract a star person from user input, I can retrieve horoscope, I can find news stories, and I can do star news write-up. And that just went straight through because all of those side effects were correctly achieved. So when it got to, let's see what these actions look like in code. So, extract star person. So, extract a person from this user input, extracting their name and star sign. Note it is built on top of Spring AI, so we benefit from a lot of the features of Spring AI in terms of automatically generating a JSON schema. But calling an LLM is significantly simpler. So you've got this fluent model for like using, in this case, LLM options auto, so it'll look at the prompt and try to work out what it feels the cheapest or most appropriate LLM is. And we have this create object if possible. Notice this return type is nullable. Got this thing in Kotlin called nullability, which is really quite cool. And there is an added layer on top of Spring AI here, which tells the LLM that there are two alternate return paths here. And if you genuinely can't do this, say so, and then it returns null and it will go back and replan. So let me just run it showing the prompts so you can see a little bit more of what it's looking under the covers. So here you can see that we'll see this create object if possible, so create a person from this user input. Let's see, okay. So what we've got is it's put in a couple of system prompts. It has the notion of prompt contributors. If you use ChatGPT but haven't used the API, you may not know that you will get absolutely terrible results for anything to do with searching if you don't put the knowledge cutoff in the system date. It doesn't know. It's in the ChatGPT and Anthropic system prompt, but the API core endpoint doesn't know. So you put this common stuff to ensure good behavior. Then you can see the user instruction, and it's also put in extra stuff. So saying you've got to be sure about every field in the response. Okay, let's get to the business end, where take the following news stories and write up something amusing. So let's go here. Take up the following news stories and write up something amusing for the target person. Word count was injected by Spring. And notice it is completely corresponds to this. Unlike a lot of the things that you will see in Python with agent frameworks or other LLM calling frameworks, completely type safe. So survives tooling, survives refactoring. How do you access tools? There are two ways of accessing tools. One is that you specify tool groups. So here this action specifies that it uses the web tool group, which gives it access to web tools. Web tools in this case come from the new Docker desktop extension for MCP Toolkit. This is really cool. Far better than using UV or how a lot of MCP tool calls you see get executed. So it is calling into like Brave Web Search through that. But tools can also be exposed on domain objects. So for example, if you have a domain object in scope, you can have tools like this. So for example, this is on the file tools, which if say you have a software project for the coding agent in scope, you can see these tools automatically exposed to the LLM. And I think that's really important, this notion of exposing tools from your domain objects. Okay, well, hopefully that was thought-provoking. I really believe that the JVM has a lot to say about the evolution of agentic frameworks, and I think the natural way to do that is using Spring and Kotlin. So, I think Java is a fine language, but, I feel happier trying to build the future in Kotlin. I believe that the potential is there not just for a more useful agent framework for business, but for a better agent framework. I think the concepts behind this are better than any of the Python things, and I truly believe that in Kotlin, we can build the best agent framework. Thank you.